How?
Polyamine metabolism impacts T cell dysfunction in the oral mucosa of people living with HIV. Hey there, scientists! Today, we're diving into the fascinating world of polyamine metabolism and its impact on T cell dysfunction in the oral mucosa of people living with HIV. Now, I know that sounds like a mouthful, but don't worry, we'll break it down step by step. How viruses alter the metabolic states of immune cells and the precise mechanisms underlying the persisting immune dysfunction during chronic viral infections are key questions that have not been fully addressed. Given that discrete tissue microenvironments govern the diversity, function, and plasticity of immune cells that in turn regulate antiviral responses and inflammatory signals, devising effective and targeted approaches requires a comprehensive understanding of tissue-specific immunology. In the era of combined antiretroviral therapy, CART, HIV infection is characterized by systemic inflammation, persisting mucosal immune cell dysfunction, and increased risk of biological aging and associated comorbidities. People living with HIV, PLWH, represent 37.7 million, 30.2 to 45.1 million, of the world population, with a significant compromise on the quality of life and no current treatments for comorbidities in PLWH1. Higher prevalence of periodontitis, oral candidiasis, and cancers are observed in PLWH, although the underlying mechanisms are less studied too. 3. Oral mucosal T helper, TH, dysregulation and hyperactivation coincide with enhanced toll-like receptor, TLR, and NLR family pyrin domain containing, NLRP, 3 driven inflammasome signaling, elevated levels of FOXP3 plus TREGs and their dysfunction in PLWH4. Our previous study has shown that HIV infection-associated TH dysregulation involved an enrichment of dysfunctional FOXP3 plus cells, TREG-dys, defined by PD1 high FN, gamma plus FOXP3 plus CD4 plus markers. Although higher expression of PD1 and IL-1 beta contributed to TREG-dys induction and proliferation, the precise mechanism of overall TH dysregulation in PLWH is unclear. Polyamine synthesis represents one of the fundamental processes and has recently been shown to determine the functional fates of TH subsets 5, 7. Ornithine decarboxylase, ODC1, is the rate-limiting enzyme in the polyamine biosynthesis pathway and converts L-ornithine to the first polyamine putrescine, which is sequentially converted into spermidine and spermine 8. Spermidine acts as a substrate in the process of hypusination of eukaryotic translation initiation factor 5A, EIF5A, which is upregulated during T cell receptor, TCR, activation and regulates cytokine expression in Th cells 5. EIF5A hypusination is a post-translational modification of a specific lysine residue that requires 2 consecutive enzymatic steps involving deoxyhypusine synthase, DHPS, and deoxyhypusine hydroxylase, DOH. These components of polyamine synthesis pathway were recently implicated in altering Th activation, cytokine expression, and cellular fidelity 5. Here we show that HIV-mediated alterations in polyamine metabolism contribute to the mechanism of tilting the balance between Th17 and TREG cell subsets in the oral mucosa of PLWH. Our previous study characterized the TREG-dys subset during HIV infection and showed that TREG-dys induction and expansion require caspase-1 activity and IL-1 beta release 4. Here we found that pyroptotic loss of Th17 cells coupled with the skewing of the Th balance towards TREG-dys phenotype also requires ODC1-mediated polyamine synthesis and EIF5A hypusination, which are also enhanced during HIV infection. ODC1 and polyamines do not directly regulate Th17 cell frequencies in the context of HIV infection. However, blockade of ODC1 activity as well as EIF5A hypusination using N1-guanyl-1,7-diaminoheptane, GC7, a spermidine analog, reduced the frequency of TREG-dys during HIV infection in vitro. The addition of exogenous polyamines also induced amphoregulin, AREG, upregulation and proliferation of TREG-dys. Importantly, in PLWH, increased TREG/Th17 ratio and CD4 hyperactivation positively correlated with the upregulation of polyamine putrescine in the oral mucosa. In conclusion, our study uncovers the role of polyamine metabolism as a cardinal determinant of Th dysregulation and chronic inflammation in the context of viral diseases. So, we all know that HIV infection is characterized by systemic inflammation and persisting mucosal immune cell dysfunction, right? Well, it turns out that polyamine metabolism plays a crucial role in all of this. Polyamines are essential molecules involved in various cellular processes, and they've recently been shown to determine the functional fates of different T cell subsets. Now, let's talk about ornithine decarboxylase, ODC1, which is the rate-limiting enzyme in the polyamine biosynthesis pathway. It's responsible for converting L-ornithine to the first polyamine putrescine, which then goes on to become spermidine and spermine. These polyamines, especially spermidine, play a role in regulating cytokine expression in T helper cells. In the context of HIV infection, alterations in polyamine metabolism contribute to the imbalance between T helper 17, Th17, and regulatory T cells, TREG, subsets in the oral mucosa. The study also found that the skewing of the Th balance towards a dysfunctional TREG subset requires ODC1-mediated polyamine synthesis and EIF5A hypucination, which are enhanced during HIV infection. But here's the really interesting part: blocking ODC1 activity and EIF5A hypucination reduce the frequency of dysfunctional TREG cells during HIV infection in vitro. Additionally, the addition of exogenous polyamines induce the upregulation of amphoregulin, AREG, and proliferation of these dysfunctional TREG cells. What's even more compelling is that in people living with HIV, the increased TREG/Th17 ratio and CD4 hyperactivation positively correlated with the upregulation of polyamine putrescine in the oral mucosa. So, in a nutshell, this study uncovers the critical role of polyamine metabolism in T cell dysregulation and chronic inflammation in the context of viral diseases, shedding light on potential new avenues for targeted treatments. And there you have it, folks. A deep dive into the world of polyamine metabolism and its impact on T cell dysfunction in the oral mucosa of people living with HIV. Thanks for tuning in, and as always, keep exploring the amazing world of science.
PharmaPal.